Hello there. I want to cover one more type of processor sharing that is supported by the QPython package, that is capacitated processor sharing. Now, the term here, I'm not sure that I would have guessed what it meant, but it basically means switching behavior after some threshold for the number of customers. And when that threshold is exceeded, then it switches over to processor sharing. If it's less than the threshold, then it does not do processor sharing. So in this example that they have in the documentation, we just have almost the same network definition as we usually have. Maybe I'll make this a little bit larger for you folks. Except that we've set this processor sharing parameter to 3. And for the sake of their example here, they set a system tracker to keep track of the system population. Now, interestingly, people have derived the theoretical probability distribution for the number at the node, and it ends up being this somewhat complicated looking result that R is the number of customers that are being served, and that the behavior switches depending on what is the case. So this is the process sharing capacity R. And we have a slightly adjusted traffic intensity that it's lambda, the arrival rate, over R times mu, where mu is the service rate. And then we have this special E2 is the Erlang function given by this somewhat complicated ratio with some expansions that comes out of the theoretical mathematics. And you can see that they plot the simulated results against the theoretical results, and the agreement is pretty good. It's not perfect, but then again, it's a simulation, so just due to sampling variation, it's not going to be exactly the same. So hopefully that is useful to you, or at least interesting for when you're building these simulations. I have to say that this is perhaps one of the less obvious ones in my mind to use, but I guess the idea is that you're modeling a service where the servers do really only one task until the system kind of hits a breaking point where it's flooded and they just start scrambling all over the place to do things, multiple different tasks here and there, and so you get a concurrency overhead. As far as I know, it doesn't support it the other way of having processor sharing for the lower below threshold, but maybe that doesn't happen as often in the real world or something like that. Anyway, it's an interesting type of mechanism for changing the behavior during a simulation for the processor sharing, and hopefully that's useful for you in simulating the system you're interested in simulating. So with that, I'll catch you in the next video. Take care.